Hello everyone, welcome to the next lecture on the Gauss elimination method. Today we will describe the 10 examples how you can solve the problem. Myself Dr. Harish Garg. You can simply follow my YouTube channel Dr. Harish Garg, where there is a playlist of the numerical analysis, and you can see there is a first lecture of the Gauss elimination method with the partial pivoting. In this lecture you can see what is the process of this Gauss elimination, and later on you can also see the others lecture as per your course syllabus. Now, what is the Gauss elimination method? As we discussed in our last lecture, this is the method for solving the system of the linear equation Ax is equal to b. In this method, you have to convert the argumentric matrix into the upper triangular form. For example, here, if this is your matrix, say A, then you have to apply the elementary row operations like R2 minus 3R1, R3 minus 1 over 2R1, and so on, and you can convert this value and this value as a 0. And once you can formulate this, make sure each of the diagonal entry must be non-zero. If the diagonal entry is 0, if I say as AII is 0, then this Gauss elimination method will fail, and once it is failed, then you are using the method of pivoting, that is called as partial pivoting, which is available at here. You may watch about this lecture so that you can understand this lecture very well. Once you can see each of the diagonal entries by non-zero, then you can use the back substitution for solving the solution of this system. So let's see how you can solve this. I can give you the 10 examples. One of the easiest way I can solve you, I will tell you one of the easiest way, as well as the shortcut trick. You can complete the entries within a fraction of a second. So first of all, solve the system of the equation by Gauss elimination. Remember always, your step number 1 is you have to write always argumentric matrix. How you write? You can write the first row 2, 6, 1 and 7. Because this is the right hand side, I can use this dotted column to them, to distinguish them. Now your target is to make these three values to be 0. So how you can make them? That's a very simple. I will tell you the simplest way. Firstly, you can write the first row as such. You can write the first row as such, and the first column as a 0. Fine. You can write this as. Now, if you remember that, how you can apply the elementary row operation like R2 and R3. How you can make these values to be 0. So if I half of this, that is R2, if I divide it by 2 of this R1 and subtract them. While in this, if I multiply this row by 5 and divide it by 2 and then subtract from the third row, this will comes to be 0, like of this one. And then you can find this expression like of 2 minus 6 by 2, 3, so that's a minus 1. This value will be 7 minus 6 into 5 over 2, this will be my 5 over 2, and so on. Fine, but that may take a lot of time to complete this table. The other way, the other easiest way how you can solve this problem is, I will tell you that since we are on the first row, you can box them. Fine. Now if I want to find this value, look at the previous value of this position. Previous value is my 2. Now 1, you always consider the one box element. Other value is my 2. You have to think the two values from this table, from this matrix, so that it will complete the box. So you can see this value will complete the box. So this value is my 6, this value will be 1. Now if you have the 4 element A, B, C, D, find the determinant of this. So you all know the determinant will be AD minus BC, but make sure wherever the box is written, you have to start from this side. Like if I say this is my box, then you have to write the determinant from here, BC minus of AD. That's the only concept behind that. So now you can see for this it is a 4 minus 6, that is my minus of 2, then divided by your box element. Fine. This box element is known as pivot element. Fine. So now based on this, you can complete all the entries within a fraction of a second. So let's see how you can solve this. So this is my box element. Previous value of this is my 2, other elements are there. So what is that? 4 minus 6, that's a minus 2 divided by box element, it's a minus 1. Look at this value, previous value is 7, one is a box element 2, other is my 5 and 6, so that box will be here. So 14 minus 30 is a 16, divided by 2 is a minus 8. Look at this value, previous value is minus 1, other two elements are 1 and 1. It is a minus 2, minus 1, it's a minus 3, divided by box element, minus 3 by 2. Look at this value, minus 4, 1, 5 and 2. So minus 8, minus 5, minus 13, divided by box element. Look at this value, previous value is minus 2, minus 1, 7 and 1. Minus 2, minus 7, minus 9, divided by 2. Similarly for the last value, it's not this, 5 and 2. So this value is 18 minus 35 divided by box element. So that's a 17 by 2. Okay. Now once you can write that, how you can write these values are there? That's again a very simple. You have to write like R2 minus R3 minus. Look at that. Based on this, what is the opposite of this? It is a 2 over 1. Write the opposite of this, 1 over 2 of R1. R1 is a box element. Similarly for the 1 and 3, what is the opposite of this is 5 over 2 R1. Fine. So once you can complete this, you can see this is my here. Now similarly you can do, now this is a pivot element, this is the box element. Now this is a second row, so you can preserve the first 2 row as such. You can write the first 2 row as such, and then because this value is 0, write this value in the denominator as a 0. Fine. How you can find this value? You can see the previous value is minus 13 by 2, box is here. Now you can start from here. It is plus 13 by 2, it's a minus 24 by 2 divided by box element. So what is that? This is my 11 over minus 1. So this number is my 11 over 2. Similarly for this value, previous value is my here. So it is my 17 by 2, it is my minus 72 by 2 divided by box element. So it is my 55 over 2. So this value will be my 55 over 2. So how you write the operation? Because we are working only for the R3, so I can written as R3 minus box element is my R2. So what is the opposite of this? It's a 8. So you can see R3 minus 8 R2. Fine. Now next one is, this is my box element. Now since there is no element below, so now we can use the back substitution. How you can write this back substitution? This column is my x1, this is my x2, this is my x3. So I can write from 0x1, 0x2, 11 by 2 x3 is equal to 55 over 2. 0x1 minus x2 minus 3 over 2 x3 is 9 by 2 and so on. So from here you can easily find the value of x3 as my 5. I can substitute the value of the x3 from here. You can get the value of x2. I can substitute the value of the x3 and x2 here. You can find the value of x1. So thus my root is, or my solution will be here. Now based on this trick, I can solve the remaining 9 questions. So solve this by Gauss elimination method. You have to firstly write this one. So what is that? How you write this element? So first element is my box. So you can write this first row as such. Fine. And the first column is my 0. Then how you find this value? This value, previous value is minus 3. It's a 3, 2 and 1. It's a minus 9, minus 2. Minus 9, minus 2 divided by box element. So it's 11 over 3. If I found here, it is my 6 plus 1, 7, 7 by 3. This value, previous value 2, 1, 1 here. 6 minus 1, 5, 5 divided by 3. Look at this value, previous value is my minus 1. Other values are 2, 2 and 3. So minus 3, minus 4, minus 7 divided by box element. Next number is 1, minus 1, 2 and 3. 3 plus of 2, 5, 5 divided by 3. And the last element will be 9 minus 2 is 7 over 3. So how you write the operations? You have to change R2 and R3. So how you can change them? R2 minus, what is the opposite of this ratio? 1 over 3 R1. What is the opposite of the R3 and R1? The opposite of this will be 2 by 3 minus of 2 over 3. Now once you can make this ratio here. Now you can make this element as a box. Then you can write the first two rows as such. This 0, minus 11 over 3, 7 over 3, 5 over 3, and make this value as such 0. So you need to write only two values. Previous value of this box element is here, so it will be minus 55 over 9 and it will be plus 49 over 9. Always LCM will be the same, divided by box element. So what is that? In the numerator part it will be my minus 6 divided by 9, it is a 3 divided by minus 11. So 3, 3, it's a 2, 3, 2 and here. Fine. So the answer will be 2 divided by 11. Same for this part, it is my minus 77 over 9 and it's a minus plus 35 over 9 divided by box element. So you can take the LCM. Now how you write this? R3, box element is R2. So make the ratio of the R2 and R3. What is the opposite ratio of this is 7 by 11. So now you can write this value as here. Now third one is, this is the box element but there is no element of the below. So you can write this is my x1 column, this is x2, this is my x3. You can write as a back substitution. From here you can easily find the value of x3 is my 7. Substitute this value of the x3 in here, you will get the x2. Substitute all values in here, you will get the required solution of this. Make sure whenever you try to make them as a box, this box element neither be a 0 nor be approximately a 0. Once this will condition, then this method will fail. We will see the couple of examples. Look at that. Solve the system of the equation with the help of the Gauss elimination as well as the partial pivoting. You have to solve the both equation. Correct up to the 4-digit places. Remember, you can see these are the 4 digits, these are the 4 digits, these are the 4 digits. If any digit is written here, it is not a 4 digit, then you have to make them as a 4 digit. So we can solve this question without the partial pivoting and with partial pivoting. Write the matrix as here. Make this element as a box. So then you can write this value as such. First row is here. This is my 59.17. Then this value will be 0. How you can find these two values? You can take the product of this and this divided by here, you will get this answer. Similarly for this, previous value is this, next two values are here. Then what will be the operation is, how you can do R2, what is that? You can see what is the R2 and R1. So what is the ratio of the R2 and R1? So it is 5.291 divided by 003. Once you take the LCM, once you take the divide, you have to write into the 4 decimal places like here. You have to write in the 4 decimal places only and this. Now next one is, this is the diagonal entries but there is no below element. You can write in this equation. Fine. Now you can see your x2 from here. You can write x2, sorry, this there is no this, so you can find the x2 from here. Substitute the value of x2, you will get here. So the solution will be this one, and you can see which is very far away from the optimal solution. X1 is my minus of 10 but it is plus of 10. It means this solution is not correct. The question arises is why it is not correct, because you can see the diagonal entries is approximately 0. So it means once you solve this system by the Gauss elimination method, this method will fail because of approximately 0. So how you can solve this? You have to solve it with the help of the partial pivoting. So what is the partial pivoting? The partial pivoting said if any of the diagonal entry in which you are written as a box is equal to 0 or approximately 0, then you are using the partial pivoting. The partial pivoting is because we are working on the first column as such. Look at that first column, look at the first box. Fine. Look at the first box and look at all those elements which are below to this box element, diagonal entries, and find the largest value in magnitude. Find the largest value in magnitude. So you can see this value is my largest value. So I can interchange, you can interchange the row. So I can interchange, you can see I have interchanged the R1 with the help of R2, because this is my box element and which is very near to the 0, so I can replace them. Now you can make this as a box element which is not equal to 0 and which is not approximately 0, and the rest of the process is similar. You can write this value first row as such. You can take the ratio and write up to here. Now again you can write in the back substitution form. You can get the value of the x2 from here and x1, and you can see which is the exact solution. How you find the exact solution? That's a very simple. You know ax is going to be given. How you find the value of the x is a inverse b. Once you solve this value, you will get this result, and you can see x1 and x2 are the exact solution. Now use the Gauss elimination. You have to round 2 digits, rounding arithmetic. What is the meaning of that? If you divide them this, it will be 0.6666, and here you have to write the 2 digits rounding. So what is the answer of this? If you write in the 2 digits rounding, it is 0.67. Similarly 5/3, so you can round them as it's a 2666. What is that? 2 digits is 1.7. So I can written like here. Then do not reorder the equations. Do not reorder means you have to solve without the partial pivoting. That's the meaning of this, and the exact solution is my. So you can start with this. This is a box element, so you can make the preserve first row, and here how you write this equation. Your target is here. You can see r2 minus something r1 and r3 minus r1. So take the ratio of this opposite. What is the ratio of this? Negative. So it's a minus minus plus. What is the ratio of -1 and 2? It's a plus of 2. That's here. Now again we can apply the same rule. I can make them box. The previous value is my this, so this number will be minus 0.67, and this number will be my minus 746.8 divided by box element. So once you solve, you will write this expression here. Similarly for this value, previous value is here. It is my -1, it is my -8, it's a -9 divided by box element, it is my 9. Similarly, if you want to write this value, it's a 4, -1, 1 and 2. So start from the box element, -4, -2, it's a -6 divided by -1. Similarly for here, it's a -11, it's a -16 divided by box element is a 27. Similarly you can find for the other elements. Now in the next case, you have to write this element as a box. You can write the first row as such. Fine. Write the second row as such. This is my here, and you can write the first column. This value must be 0, and you have to operate this one. Again the previous value is my this. You can start from here, this minus this divided by, that is 7.5 into 6 minus 9 into 2.4 divided by box element. You will get this answer. Similarly for here. Then how you write this operation? You are working on the R3, so I can operate R3. Box element is on the R2. What is the opposite ratio is? 9 divided by here. So you can found this and write only in the 2 digits rounding. So you can see 2 digits rounding as a 1.2. Now you can make this as, but there is no element. So now you can write this column as x1, x2 and x3. You will get here. So from here you will get x3. Substitute this value at here. You will get the x2 and so on. So you can see the solution will be my here. You can see which is far away from the here. The reason is because of rounding. So it means it contains some errors due to rounding. Fine. But if you write instead of this number, if you write this number as 0.666 up to the 4 or 5 decimal places without rounding, then you will get the exact solution as here. Look at this question. Again you have to write this solution. You have to write the first element, box element here. Then I can write the first row, second row, and rest you can do it yourself. So this is 4 minus 4, 0 divided by 1, 0. This 1 minus 4, 1 minus 4 minus 3 divided by 1 minus 3. This value 1 plus 4, 5. This number is 11 minus 8, 3. Fine. So how you can write the R2, R3 and R4? So you can see what is the opposite of this? 4. 4R1. Opposite of this 1. What is the opposite ratio of this? 2R1. So once you can do, you can write the calculation as here. Then you can write this as a box element, but you can see this is 0. So it means the Gauss elimination method failed. So what you can do, you can look at this box element, look at the below values. These are the below values. Find the largest value in magnitude. Find the largest value in magnitude. So what is the largest value in the magnitude is? This number is my 2. This is my largest value in here. Now you can, this is my third row. So you can interchange the third row and the second row. So I have written like this. Then you can make this element as a box. Write the first two row as such. You can write like here. Then how you find this number? This is my box. This is my plus 6, 0. It is my minus 2. Minus 10, 0. Minus 10 divided by minus of 2 is 5, and so on. You can write these other values as such. How you write this? You can see I can write as a R3 minus, what is the ratio of this? It's a 0. So there is no need to write that. Now after that, this number you can see, this number is not 0. This number is not be approximately 0. Now your target is to make the first row as such, second row as such, third row as such. Then this value will be 0. You need to compute only the last two values. How you can find that? You can see how you can find this value. This is my box element. Now you can start from here. It is 9 by 2 minus 5 divided by box element. So it is my minus 1 over 2 divided by minus 3. It is 1 over 6, and you can see the answer is 1 over 6. Last step is you can box them, but there is no element, so you can write in this back substitution form. From here you can get x4 is 0. You can substitute this, you will get x3 is my minus of 1. You can substitute here and you can get the required solution as here. Okay, look at this next one. You have to solve this question with the help of the partial pivoting up to the 4 digits arithmetic. Means you have to write each digits up to the 4 digits. So they are not the 4 digits, they are 4. Now you can write. Now look at the partial pivoting. What is the meaning of the partial pivoting? Firstly, you can make them box. Look at all those values in the below. Find the largest value in the magnitude. What is the largest value in the magnitude is? This value. That is in the third row. So I can interchange the third row and the first row, because it is, although 7.79 is not approximately 0 but also not equal to 0, but the statement said you have to solve this question with the help of partial pivoting. The partial pivoting means the first diagonal entries or the diagonal entry must be the largest among the row column. So you can write, since A31 is largest in the magnitude, then of the first diagonal entry you can change them. Now you can make this value as a box. I can write this value as first row, I can write as such, and here. How you can write that? The one way is, you can see 1 divided by of this. Once you can calculate, you have to write up to the 4 digits. So the 4 digits of my here. They are not talking about the rounding off. You can simply write the 4 digits. And what about the others ratio? It is my 1.331 divide, sorry, this will be 0.7290 divided by 1.331. So that number will be here. Now how you find this number? You can use your calculator, this into this minus this here divided by box element. Otherwise you can use these operations. You will get here. Now again you have to apply the partial pivoting. Look at the diagonal entries and find the largest value in this column, but make sure you have to look from the below, not for the above. So this is the largest value, so I have to replace R2 and R3. The student will take a mistake that they have to take the maximum value of this, but this is the upper value of the diagonal. You have to look for the below diagonal, so I have to replace them here. Now again, this is my diagonal entries. Now you can preserve the 2 rows and you can find this value as such. What is the operation you have to operate? R3. What is that? You have to take this ratio 0.09090 divided by 0.1473. so once you take, you can write up to the 4 digits that's come to be here. Now finally you can make this value, but there is no other values. Now you can write this preserve. You can find the value of x3 from the first equation. X2 and x1 is the required solution of this problem. Look at this another category. How you find the inverse of the matrix A by using the Gauss elimination. That's very simple. The simplest way is, you can see I can use this identity. Fine. So I can write this matrix as here. The first value is my A and this value is my I. Then your target is to convert this matrix into this form. The first value, the first 3 columns are my identity and the next values are my updated values. Fine. So this, the values of this matrix is my A inverse. Why? Because if you written this number as here, if I multiply A inverse of this, fine, so you can see this number are here, or I can return this number as A of this is my here. So how you can make them? Your basic target is to make this value as a 1, this as a 0, 1, 1, diagonal as a 1, and the below and upper are 0. That's very simple. Firstly, I can make this row values as 0. This is the operation we can operate. So this is my box element. Now what is the value of this? 18 minus 16, that is divided by box element. This value is my 1. Similarly for this second value, minus 6 plus 8, minus 6 plus 8, 2 divided by box element 1. Same operation as here. 0 minus 4 divided by box element minus 2. 2 minus 0, 2 divided by box element 1. 0 minus 0 box element divided by here. Similarly you can compute these elements. Fine. Now you can make this element as a box. I can preserve this first row complete. I can preserve this second row, and I can write this column as 0, this value as 0. I need to find these 4 values. Then how you can write this operation? You can see I have to make this value as a 0. This is my box element R3. What is the ratio of this? 1 of R2. Now you can start with this. 5 minus 1, 4 divided by box is a 4. Previous value of this is 1, 1 plus 3, 1 plus 3. So 3 divided by box and so on. So you can find this number. Now this is a Gauss simulation. Now your target is to make this value also as a 0, so that it becomes a I. So how you can do? Now you can operate this as a below 1. So make this value as a first diagonal entries. You can make this value as the first diagonal entries. So it means preserve the third row only. Fine. Preserve the third row only. That means you are doing the Gauss elimination through below to upward. Fine. Now remember, this is my box element. So how you find this element? The previous value is my this, other 2 elements are here. Then you can find the determinant. This value, this value, this value and this value. Now there is the main thing. You have to start from the box element. This is my 8 minus 0 divided by box elements. The answer is my 2. Look at this value. Previous value is my 4 minus 2, 0 and 4. Start from the box. 16 minus 0. 16 minus 0 divided by box is a 4. This is over. Now you can find this value, this value, this value, this and this. 4 plus 6, 10. 10 divided by 4, 5 over 2. Look at this one. 0 minus of 2 divided by 4. 0, 1 minus 2. 0 plus of 2. 0 plus 2 is 2 divided by box here. Similarly you can find these remaining entries. So then what will be the operation is, you can change the R1, you have to change R2. Now this is my box element. Take the ratio of this. Fine. Take the ratio of this. So it's a minus 2 divided by It's a minus 2 divided by 4. It's a minus half. So minus minus plus of half. Take the ratio of this 1 by 4. So either you can operate this, you can complete this value as. Now you have to move this, take this as a diagonal values and make this value as a 0. So I can preserve the last row. I can preserve this value minus 11 by 4, 5 by 4, minus 1 by 4, and I can write this. So I need to compute these 5 values. So start from the box element. 0 or 2 minus 0 divided by box. Fine. This value will be 0, 0. This value will be 5 over 2 minus minus plus 44 by 4 divided by box element. So it's a 11. So it's a 22. 22 plus 5, 27 over 2, and so on. You can find this value. You will get this as the required expression. Fine. Now, or otherwise you can write like this way. Otherwise you can make this value as a 1. How you make this value as a 1? I have divided this value by 1, 4. Okay. Otherwise you can find this value as a, there is no worry about this. So now you can make this as a diagonal entries. You can complete these other values as here. Now your target is only to make this value as a 1. How you make? I can divide the first row by 2. So you can see this value is minus 11 by 4. I already computed as minus 11 by 4. 5 by 4 minus 1 by 4. This is the same way you can compute them. And this value is at 27 by 2, and you can see it is at 27 by 2. Either you can apply firstly or later, that's on your choice. Now you can see this value is my I. So this number is my A inverse. So this is the way you can compute the inverse of this matrix. Okay, look at this one. Solve the Gauss elimination. There is no partial pivoting needed. You have to write this. Make this value as a 1. So I can preserve the first row. Okay. So I have to make R2, R3 and R4. So how you make them R2 and R3 as a 0? So I can return this number firstly as such. Minus minus diagonal entry is my R1. So write this number R2 and R1. So R2 firstly, R1. 2 divided by 1 is a 2. 0 divided by 1, 0. Minus 1 divided by 1 is a minus 1. It's a plus 1. Fine. So how you can compute? Either you can use this operation, or otherwise you can use this shortcut trick. Previous value is my, for this case, previous value is minus 1. Here, these are the 4 elements. Minus 1, minus 2. So it's a minus 3 divided by box is a 1. Next number is 3 minus 2. 1 divided by 1 is 1. 0 minus 2 divided by box element. Remember, always divided by box element. Last element is 3 minus 6 minus 3 divided by box element, and so on. Rest of the value you can compute. Now this is my box element, which is not a 0 and also not equal to 0. So you can preserve the first 2 row and here. Now this is my box element. Now you can write this value. Previous value is 0. It's a 0 minus 2 divided by box element, 2 over 3. This value, previous value is my 3, 2 and minus 2. Minus 9 plus 4 minus 5 divided by minus 3 is a 5 by 3. Look at this value. Previous value is my 1, minus 3 and 2. It's a minus 3 minus minus plus 6 divided by box element. It is my minus 1. Same way you can find these 3 values here. Now make this value as a diagonal, because there is value here. Now you can preserve the first 3 rows and you can find this value. You can see this value will be 0. Now you can see how you can find this number. It's by 8 upon 9 minus 50 over 9 divided by box element. So it is my minus 42 over 9 into 3 over 2. So it is my 3. It's a 6. 6 into minus 7. It's a minus 7, and so the last number you can make this as a box, but there is no below element. Now you can write as a back substitution. From here you can find the value of the x4. From here you can find the value of the x3, and so on. So your required solution will be here. Now again you have to solve this problem with the help of the partial pivoting. Fine. So what is the meaning of the partial pivoting? You can make the first box, look at the column, first column, and below this diagonal, below this box element, what is the largest value in the magnitude? What is the largest value in the magnitude? That is my 4, which is written in the row second. So I can interchange the second row with the help of first row. So I can interchange completely here. Now make this element as a box, then you can write this only. Again, I think you can easily write this operation because our target is to make this. So what is the ratio opposite of 2 by 4? 1 by 2. 1 by 4 is here. Then I can make this value here. What is the value of this? 8 minus 4 divided by box element. So 4 by 4 is a 1. Previous value is 1, 3 and 2. 4 minus 6 divided by box element is a minus 2 over 3. This number is 4 minus 4, 0. Similarly, you can compute these three positions. Now again, you have to do the partial pivoting. You have to put as a box here. Look at the below elements of this box. What is the largest element? Largest element is itself a 1. So there is no need to, in this case, there is no need to change the row because the diagonal entry itself the largest value. Then you can make this element as a box, write as a below 0. What is the value of this? You can see it's a 1 over 4 minus minus plus 1 over 4 divided by box element. It is 1 over 2. This value will be 5 by 2 minus 0. It's a 5 by 2 divided by box element is my here. Now since there is no more elements are there, you can use the back substitution. Clearly says x3 will be your 5. You can substitute here. x2 will be my 5 by 2. Substitute this value here. You will get the required answer as here. Look at the another question. Do not reorder the equation, means there is no need to partial. You have to use the 2 digits rounding off. So like 1 over 3, it is my 0.3333, but you have to use the 2 digits rounding. So what is the rounding of this is 0.33. So I can make this value. Okay. Now again you can apply the same procedure. Write this as a 4. You can put as this. So what is that? This is 0.44 minus 0.22 divided by 4. It is 0.22 divided by 4. Write only up to the 2 digits. So this is 0, 5, 5. So you can write this as 2 digits up to here. Fine. 2 digits. These are my digits. These are my digits and here. Fine. So 2 digits arithmetic. 0, 0 is not a digits are. Now although this value is my approximately 0, but the question suggested you do not reorder. Fine. If this is not given to you, then because this number is approximately 0, then you have to use the partial pivoting. But this question suggested you do not reorder. So it means you have to proceed as such. Then you have to make the first 2 row as such, and you can compute these values by using this box element. Now you can use the back substitution. You can find the value of x1, x2 and x3. Now clearly says the value of the x1 is very far away from this exact solution. How you can find the exact solution? You can easily solve this by A inverse B. Similarly x2 you can see very far away. The reason of this results is very far away is because of rounding and because there is no partial pivoting applied because this number is approximately 0. So the reason behind is, in this case the solution is quite wrong due to the rounding of error and the diagonal entries are almost 0 but without using the partial pivoting. So remember, always use the partial pivoting if nothing is given to you in this state. So I hope you can simply learn the various concepts and the shortcut tricks for solving such problem. We can see the next lecture on the Gauss-Jordan methods for finding the solution. Till then, you can simply like, share and comment on my video. Best of luck students. Happy learning.